Hi everyone, I'm Claire.
And I'm Isaac.
And we are back.
We're back.
We are back for the new Welcome series, Meet Extreme Switching. So why switching, Isaac?
It's the stuff that made us famous. I mean, we're a networking company, we make switches, and we do them well.
We do them well, and we're hoping to explain this to you in 5 episodes. So does anyone need to know anything about extreme switching before doing this course?
Good question. No. There's no pre-requirements for this, but this is going to act as the prerequisite for the professional program. So anybody who wants to know more about extreme switching or do further training, you have to pass an exam, and you're going to tell us more.
Exactly. So this does come with a certification exam, which you guys know the drill. Stay tuned to the end of episode 5 where I'll be taking you through how to gain access to that exam. So for this episode, what have we got coming up for episode 1?
We don't assume that everybody knows what a switch is, right? So we talk and we define what is a switch. We look at the history of the operating system called EXOS switch engine. We look at how we got to all of that. And then we go a little bit more into the hardware and show you all the bits and pieces of what a switch actually is. So, going to be interesting, yeah?
Yeah, pretty jam-packed episode.
Yep.
Are we ready to go?
We are. Let's go.
Let's go.
So what exactly is a switch? It would be unfair to assume that everybody knows or has seen what a switch is. But in essence, a switch is a device, a hardware device that connects humans on the one side to resources on the other side. And those resources could be in a corporate environment, they could be a central printer, they could be a security system, they could be access control, they could be connecting to an HR system or a finance system. All of those pieces need to be connected together. The switch is the device that enables that. In your home, you might also have a switch. It might look slightly different to what a corporate switch looks like. Probably be a lot smaller, a lot lighter, a lot less features, but at its very simplest, it's creating connections between humans, devices, resources. Extreme Networks as a company has been around since 1996. And in all that time, we've built up a great reputation for making fantastic hardware, fantastic switches. But the thing we're most famous for is this purple color that we've painted our switches. Of course, it doesn't add anything to the functionality of the technology, but it looks really great. And if you've ever walked into a data center that has our equipment, you walk in and that purple is so easy to identify. Now, as a networking company, switches was the first thing that we've done. And of course, we've grown. We now do wireless technology as well. And of course, we do management software. So we really do an end-to-end networking solution. In all that time, we've grown organically and we've also made acquisitions. We've bought in different types of technologies and different companies and taken their technologies, integrated them into the stuff that we sell. And today we have a portfolio that can compete with any of the major players. Of course, this is going to affect the naming of our products. As we've acquired technologies, we've also acquired names. That can lead to a little bit of confusion about the naming of our products, and I'm going to explain the naming specifically of our switches and the operating systems that run on these devices. So take this journey with us. It's a fascinating one as we go into the world of switches. You're going to hear me talk about 2 operating systems throughout this series, and I'll use them interchangeably, even though I'm going to try and focus on one specifically. I'm going to talk about EXOS and I'm going to talk about switch engine. EXOS standing for Extreme Operating System. Every switch that you buy from any manufacturer is going to have an operating system on it. Up until a point in time, we used to refer to that operating system as EXOS. Then we introduced about 2 and a bit years ago, we introduced the concept of something called universal switches. And the reason we did that is because we had this great technology called Fabric, and we used to make switches that ran Fabric. And then we had other switches that ran EXOS. And you can imagine it means two separate devices, but essentially the same physical switch. So we brought these two operating systems into a space where we could give a customer a choice of which one they wanted on the same physical device. Universal switching. So you can now buy a device from us, a purple switch. That device has the ability to run two operating systems on it. Either Fabric, and if you're interested in Fabric, the previous Welcome series that we did covers that in detail. So you could run it as a Fabric switch, or you could run it as EXOS. Now, when we introduced Universal, we stopped calling it EXOS. We now call it Switch Engine. It is the same operating system, the same computer code, the same everything. It's just a name change. So for the purposes of this series, we will talk about Switch Engine. For those of you who already have our gear in place, that just translates to EXOS. That's all it is. But let's talk about Switch Engine. Why is it great? Why the universal switch? Why that technology? Why would we introduce it? Just think about existing customers who have these networks in place. They want to buy a new device, they can buy it, and it can fit into the existing infrastructure. If at some point in time they decide, ooh, we'd like to be able to upgrade to Fabric because now we have multi-site, a campus, for example, it would work a lot better in those environments. Guess what? If you have a universal device, you can just bounce it again and bring it up as a Fabric switch. You as a customer have a choice which one you want to run. And at any point in time, without having extra licenses or anything like that, you can just switch it to another operating system. This gives you the option to design a network, deploy a network, build a network, and when you need to, redeploy it again. Extreme universal switching and the naming conventions that have brought us here. In our networking world, we use terms, we use terminology that oftentimes just makes sense to us and not to people on the outside. And if you hang around with networking engineers for any significant period of time, you're going to hear them talk about layers. You're going to hear them say things like edge layer or aggregation layer or core layer. So they'll refer to those terms. Firstly, let's talk about the edge layer. What that edge layer does is it simply refers to the layer at which humans, connections, devices connect into their network. So imagine you have a laptop and you're walking around the office. That laptop is probably connected to the office using a wireless connection. So what is the first device? What is the first network device that your laptop connects to? Well, it would be that access point. That is the entrance into your network. That is an edge device. If you're connecting, for example, a printer into your network, then your printer, your physical printer, if it's one of those big office ones, it would have an Ethernet cable that runs all the way from the back of the printer into a switch in a data cabinet somewhere. That switch, that's the edge of your network. The first entry point for the devices that you use to connect to. That can be a couple of hundred of them in big enterprises, hundreds of devices. Or if you think about your home, it could be one single device because you plug your printer in, you plug your TV in, you plug your Xbox in. All of those are going into the edge device. The next layer is what we call the aggregation layer. Let me use that example of edge I spoke about when I said you could have hundreds of these switches or access points sitting on the edge. If you have all of these switches and access points, all with users connected into them, hundreds, maybe thousands, where does the data that comes out of these switches go to? That goes to an aggregation switch. An aggregation does exactly what it says on the tin. It aggregates the data. It pulls in, it collects the data from all those hundreds of switches into a much more powerful switch. It still has the Ethernet ports, it still has fiber optic ports, it's got all of that, but it's much more high spec, much more high speed capabilities. The aggregation layer, the layer behind the edge that sucks in all of the data. And then what do you find beyond that? You find the core, what we call the core, and that generally sucks up the data from the aggregation layer and traverses it, pushes it out onto the internet, the core layer. So those are the terminologies. That's the terminologies that network engineers and networking companies sell their products by. They will sell you switches or devices for the edge, devices for aggregation layer, and devices for the core. Now that has simply been, or that has been for a long time, the normal, the classical approach to building networks and to naming networks. There is a different approach as well where the core is taken out and you just have the edge and you have the aggregation layer, because switches nowadays on the aggregation layer are able and capable to connect you. Now certainly extreme network switches do both layer 2 and layer 3 connectivity, which means they are able to get you directly onto the internet. So we have a classic model and we have the more modern approach to doing networking. We've spoken a lot about the capabilities that these switches have, that the operating system is able to do. Let's look at a couple of switches. We've brought two into the studio. The first one is a Summit 480. It's one of the older switches that we have. We'll start from left to right and we'll work our way around the switch. So firstly, on the left-hand side over there, you'll see the old connectors that we used to use to get into the console. That would be what we call a serial connector, a 9-pin connector. Next to those, we have other ports. You can see that they are blanked, similar to this, and we'd use those for stacking, for example. The next ports that we have over there are the traditional RJ45 ports with different capacities, from 100 megabit per second, a gig, 10 gig, for example, 40 gig if necessary. Then you'd have over here these ports, again, which are all blanked out. Now, the design around this is so that the customer can choose how they want to use these switches. This gives the customer options. So they can have these ports over here, they're SFP or SFP plus ports, and they can contain different types of fiber optic connectors. To the right, we then have the management ports, the switch management ports. So the RJ45 and a USB connector as well. And finally, on this side, right down the bottom on the right-hand side, is an indicator LED, which shows which member this is in a stack. Stacking allows you to take up to 8 of these and make them behave as if they were a single switch. So that gives you that indication of what the stacking is. On the left side of the switch, we have the mounting plates. They, of course, can be moved forward and backwards depending on how deep you want to set them into your rack. And then, of course, these would clip into your calipers in the back of the rack so that you could pull it out and push it back in when you needed to do any changes. The height of a switch is normally measured in U's or RU's. That simply signifies this is 1 RU. And you have most other switches that also have that same height. Standard heights, standard widths for any communications rack. Moving to the back, we have a couple of interesting connections over here, a couple of interesting devices. On this side over here, we have the fan setup, the fans. And you can see that we actually have a blanking panel as well if you wanted to purchase additional redundant fans. What do they look like? Let me pull this out. That's what the redundant fan little unit looks like. It just slides into there. This one has 3 fans connected to it. The next one is the power supplies. So here you see two different power supplies. Yes, you would physically have two cables into there, and they would both be plugged in and running at the same time. So these are redundant power supplies. They probably came with one, and then you can go and add another one. To remove that, you just click on there and you pull that out. So that is the redundant power supply for one of these. That's quite a big beast. It's quite heavy, really solidly built. And the reason that you would want this is because it's not uncommon that these devices have to be used in mission critical applications. So the last thing you want is for a switch like this carrying huge amount of traffic to go down because of a single power supply. So generally speaking, any environment that requires redundancy, please purchase two, or some of them might even have more than that, power supplies. If one goes down, the device is still able to be powered from a single one of these power supply units. And on this side, there's nothing much to see. It's just the same as the other side. And that's what one of the older switches looks like. So let's go now have a look at what a newer universal switch, the 5420, looks like. So let's go again from left to right on this 5420 series. One of the neat new innovations that they have on these universal switches is this little paper tag. When you pull it, you'll see it's got a QR code on it, but it also has the serial number of the device, the MAC address of the device, the part number of the device. That's really, really cool. When you put that in, you have two USB-A ports over there. You can plug in a USB to update, for example, the firmware if you want to do it that way. Or if you need to charge your phone, you can just plug it into that USB port. Next up is the console and the management ports, those top two ports, followed by underneath you have two blanked ports. Now those are the stacking ports. You can use them as 1 gigabit or 10 gigabit stacking ports. Remember, you need special cables for those. Stacking, you can have up to 8 of these devices in a stack, turning this essentially into a single switch with 8 by 36 or 48 ports. The next thing that you have over here is the uplink ports. Again, these uplink ports come with SFP plus connectors or blanks, and you would need to purchase the connectors that you need for whatever use case you need, short distance, long distance, etc. After that, you have Ethernet ports. There are 48 Ethernet ports on this particular switch. Moving to the left of the switch, you can see at this point we don't yet have the mounting brackets connected to this model over here, but that's just in the packets, and we'll connect that up later. Moving to the back of the switch, unlike the previous switch we saw a few minutes ago, this one doesn't have redundant fans. It's got 3 fans, but none of them are redundant. Now, it does have a built-in power supply, and then it has the blanking panel if you wanted to add a second power supply into this model. Right, coming to this side, it's exactly the same as the previous side, nothing new to see, and we'll bring this device around. Really great piece of kit, not as heavy as the previous model, shorter than the previous model, but again, a 1U rack model. Now this model over here is actually the 5420F-16W 32P 4XE. It's a real tongue twister, but there's actually logic in the name. The 16W means these 16 ports here have 802.3 BT power, meaning they are able to offer 90 watts of power to power up devices like security cameras, for example. For the next 32 ports, you have 802.3 AT power, which is 30 watts of power. And that's going to power up things like security systems or even an IP telephone on your desk. The 4XE means those 4 optical ports that you have. Just want to cover a few more points with these switches. And the first is the power. Most switches will have AC power on them, but we do have a smaller range of switches that have DC power as well. It's really a small range. The ones that I've seen are desktop switches, 16-port switches, and pretty silent switches, so their fans don't come in until a certain point in time. So you have the ability to have both of those options. Another term that you will come across is VIM, V-I-M, Versatile Interface Module. This switch also doesn't have that, but would be a component that would plug into here that gives you the option of having a different type of connection method. Some data centers use the concept of hot and cold corridors to help them extract the hot air out of the data center as quickly as possible. Some extreme network switches have capabilities that will help data centers manipulate that airflow. Generally speaking, hot air is pushed out the back of these switches. Some of them, not this particular model, but some of them have the ability for you to change the direction of the airflow and to push it out through the front. So why would you want to change the airflow? Well, if you're in one of those hot corridors, you really don't want the airflow to be blown into a cold corridor. So you would reverse that and the air would blow out the front into that hot corridor where they can then extract it to cool it down. Blocked and unblocked switches. What do they actually mean? Well, a blocked switch is a switch that does not have the capability to push the maximum data rate right across all of these ports full time, all the time, 24 hours a day. It would block some of that. An unblocked switch is a switch like this one that is able to transmit and receive data at the maximum rate, 1 gigabit per second, on every single one of these ports. In no way is this a comprehensive end-to-end explanation of what these switches are capable, what the physical switches have in there. But if you go to the extremenetworks.com website and you go look for the data sheets on these switches, there you will find accurate information on what the full capabilities of this switch are. In summary, we've looked at Extreme, our history, how our acquisitions have affected our naming products. We've spoken a little bit about universal switching, what that actually means, the benefits. And then we got into describing the different layers that network engineers use when they talk about networking products and technology and approaches to the way we build networks. We then looked at hardware, actual switch, and we went through all the different components, and hopefully that has kind of brought some light. If you weren't aware of all the names and all the components, that has made it easier to understand. And so we've covered quite a lot in this episode. I look forward to seeing you on the next one.